trigonometric functions of any angle. So we're going to let theta be an angle in standard position with xy as the point on the terminal side of theta. And then we can say that r, really the radius here, is going to be equal to the square root of x squared plus y squared, as long as it's not 0. So really r, again, is your radius. So if we have some sort of angle, okay, and we're on the unit circle, this is my radius, and we can drop this down to make a right triangle. So we have the x value, the y value, and the r value. So really what we're saying here is that our sine is going to be, if this is my angle in here, right, it's going to be opposite over hypotenuse, which is y over r. Usually r on our unit circle is going to be 1 because the radius is 1 unit, but in this case it could be something other than 1. Our cosine, sorry, this is so out of order. Our cosine is adjacent over hypotenuse, so x over r. Our tangent is going to be opposite over adjacent. My cotangent is going to be the inverse of that. Secant is the inverse of cosine. And cosecant is going to be the inverse of sine. I think this got maybe a little bit messed up when I did columns. Okay. So really it's the same idea here. We are just going to, keep in mind that we're not necessarily talking about the unit circle, but any circle. So because the radius is going to be equal to the square root of x squared plus y, which is really Pythagorean theorem, right? X squared plus y squared should be r squared, the hypotenuse, but we could just take the square root of both sides. And we know that it cannot be equal to 0. Then our sine and cosine functions are going to be defined for any real value of theta, right? Because if r was 0, then we'd have a denominator of 0, and that just doesn't work. So when x is 0, the tangent and the secant are going to be, right, tangent and secant, if x is 0, would be undefined, right? Y over x or r over x. For example, tangent of 90 degrees is going to be considered undefined. And when y is equal to 0, then our cotangent and cosecant are going to be undefined, again, because that's the denominator, which can't be 0. So let's take a look. We're going to start with this point. So we're going to be given some random point. Here's angle theta. We don't necessarily know what it is, but we have this point at -3, 4. So what we're going to do is find sine, cosine, and tangent given this information. So we could do a few things. Personally, what I like to do is to draw a triangle. So kind of as if you're doing a reference angle, which would be the acute side. We have our right triangle here, and here is that reference angle. We're going to put theta prime there. And then what we have to do is really think of the measurements. So the x value, that is 3. The y value is 4. Now I know it says -3, but we can deal with that in just a minute. And then our radius. So this is a triangle that we know. Our triangle with the 3 and 4, that means the hypotenuse is 5. We could use the Pythagorean theorem if we don't know that. All right, so we want to find sine, cosine, and tangent. So for the sine of this angle theta, that would be opposite over hypotenuse, so that's 4 over 5. We'll get to the plus or minus in a minute. Cosine of theta is going to be adjacent over hypotenuse, so 3 over 5. And our tangent is, sorry if you hear my dog in the background, our tangent is going to be opposite over adjacent, so 4 over 3. So the last thing I want to double check is, should it be positive or should it be negative? Now, remember we talked about the other day, all students take calculus. We are in quadrant 2, so that means only sine should be positive in quadrant 2. So sine is positive, but that means cosine and tangent will both be negative, which should make sense seeing as this 3 is negative, right? All right, so again, just kind of to reiterate from the other day, when we are in these different quadrants, this is that all students take calculus to help us remember these. So the signs for trig functions for the 4 quadrants can be easily taken from the definitions of the functions. For instance, because cosine is going to be x over r, it's going to follow that cosine is positive whenever x is positive, which is going to occur in quadrants 1 and quadrants 4. Remember, the radius is always going to be positive because that's a distance. It's a measurement of the space from the origin to the outside of your circle. Okay. All right, so we're going to be given some information, and we're going to try to figure out the sine and cosine, or whatever they're asking for in this particular situation. So we are told that sine is going to be equal to -2/3. Now remember, my radius is never negative, and my sine, if we look at before, my sine is going to be y/r. Okay, so sine, that's y/r. Which means that my y must be -2 and my r is 3 because my radius is never negative. Okay. I also know another thing. I can figure out what quadrant I'm in. I see that sine is negative, and since it says that tangent is greater than 0, I know that tangent is positive. So if I think all students take calculus, it can't be in all because sine is negative. It can't be in S because sine is negative, but it can be in tangent in the third quadrant because tangent is positive and everything else is negative. Okay, so the next thing we want to do is find what cosine and cotangent are for whatever this angle is. So we're going to draw a triangle. Okay, whoops. I mean, it doesn't matter. Sometimes it's helpful to kind of draw it as if you were in that quadrant. So I'm just doing it this way. You don't really have to. It doesn't really make a difference. All right, so there's the angle, or really, I guess, the reference angle in this case. Right, triangle, right? We would be on the quadrant like this. So our y value is -2. Our r value is 3. So in order to find the cosine, we need that extra side of the triangle. We're going to do the Pythagorean theorem here. So a squared plus b squared equals c squared. So I'm missing one of the sides. We'll call that x. So x squared plus -2 or +2 squared is equal to 3 squared. So that's x squared plus 4 is equal to 9. We'll subtract. So x squared is equal to 5. That means x is going to be either positive or negative square root of 5. And really that's going to be dependent on the quadrant we're in. So since we're in this second quadrant here, it's going to be -√5 because of the x-axis being negative there. Okay, so we got -√5. Now we want to find the cosine. Because of the quadrant that we are in, we already know cosine is going to be negative, and that'll get kind of reiterated by these numbers on our picture. So cosine is adjacent over hypotenuse, so that's -√5/3. And then cotangent we want. Well, cotangent would be the flip of tangent. So tangent would be -2 over -√5. So cotangent is -√5 over -2, or just +√5 over +2. And it should make sense that cotangent is positive because tangent is positive. And when I flip a positive number, I still get a positive number. All right, in B, so we are given that sine is 4/5, tangent is positive, it's greater than 0, find cosine and cosecant. Again, I want to know what quadrant I'm in, so I know that sine is positive, just because 4/5 is a positive number. I see that tangent is positive. The only place that more than one thing is positive is that first quadrant, okay? All students take calculus. Otherwise, something is going to be negative in the other quadrants. All right, so I must be in quadrant 1. So I know that sine is going to be opposite over hypotenuse. Okay. That means, again, this is a 3, 4, 5 triangle. If you don't recognize that, Pythagorean theorem is fine. So we want the cosine for this angle. I'm really sorry if you hear my dog walking. His nails are kind of long. So that would be 3/5. And then the cosecant that they're asking for would be taking sine and flipping it. So that would be 5/4. In reality, they could have asked me for any of the trig functions, and I could have come up with the answer. All right, and we're going to find the trig functions for quadrant angles, which really isn't as bad as it sounds. So if we have our quadrant angles, so that's 0 radian, we've got pi/2, pi, and 3 pi/2. As long as I know the coordinates that go with them, then I have no problem, right? Because x is going to be cosine and y is going to be sine. So over here, if I'm on my unit circle, that's really 1, 0. Up top, that's 0, 1. On the left, that's -1, 0. And down below, that is 0, -1. So really, I can find sine and cosine pretty easily. So if I want sine of 0, that is going to be equal to, remember, cosine and then sine. So that equals 0. If I want cosine of 0, I'm going to get 1. If I want sine of pi/2, that's going to give me 1. If I want cosine of pi over 2, that's going to give me 0. Sine of pi, cosine sine, is going to give me 0. And then cosine of pi is going to give me -1. Sine of 3 pi over 2 is -1. And cosine is going to be 0. And I believe that's it for that question. For the next question, we want cosecant and cotangent. No problem. So if I want cosecant of each of these, cosecant of 0, cosecant of pi over 2, all I'm going to do is flip the sign over for those. So here's the only thing. When I flip over 0, technically I get 1 over 0, and that is undefined. Okay. Cosecant of pi over 2, so when I flip 1, I get 1. Cosecant of pi, again, that's going to be undefined because I flip over the 0. And then cosecant of 3 pi over 2, when I flip -1, I get -1. Now, cotangent is really the flip of tangent. So if we know that tangent is going to be sine over cosine, we know that cotangent is going to be cosine over sine, right? Just flipping it over. So if I want cotangent of 0, cosine is 1, sine is 0, that's 1 over 0, that's undefined. If I want cotangent of pi over 2, that would be cosine over sine, that's 0 over 1, or just 0. If I want cotangent of pi, that's going to be -1 over 0, or just undefined. And if I want cotangent of 3 pi over 2, that's cosine over sine, or just 0. Remember, it is okay to have 0 in the numerator, but it is no good to have 0 as your